Let's take a look at this problem. We got f of x is equal to x squared minus 2 over x. And part A says to find a slant asymptote. Well, we have to use long division. So we're going to divide x squared minus 2 by x. Now we're going to rewrite that because we're missing one of our terms. We're missing the 0x. Remember, if you're missing any powers, then you have to put 0 placeholders. Now, we're going to go through our long division. So I'm going to look at the first term of each, and you ask, what do you multiply times x to give you x squared? Well, that'd be x. Now, whatever you put up on top, you multiply by what's out in front. X times x is x squared. We're subtracting that line, which means flip the signs, so that becomes a negative. X squared minus x squared drops away, 0x drops away, and we bring down negative 2. Now the slant asymptote, you use long division, and then you drop your remainder, so the negative 2 goes away. So our slant asymptote in this problem is y is equal to x. Now this problem is specifically asking you to find a slant asymptote. But if it wasn't asking you, you have a slant asymptote when your degree of the top is exactly 1 larger than the bottom. See how the degree of the top is 2 and degree of the bottom is 1? That's what tells us we have a slant asymptote. Now in terms of our second part, whenever you're working with a rational, single fraction with x's in it, if you have more than a single x or single number on the top or bottom, put parentheses around it. So put parentheses around the top. We don't have to have them around the bottom, although they don't hurt. So to graph it, we're going to press y equals, press clear, beginning parentheses, x squared minus 2, closing parentheses, divided by x, and then graph. And let me actually sketch the slant asymptote. Might actually get a little bit more precise graph. As close as I can get it anyway, by hand. And then down here, something looks like that. So that'd be our answer.